So there's some shit where you can fit like 100,000 Earths inside the fucking sun
Just yeah, but
and shit. Like,
uh, when don't ask questions till I'm done. Otherwise, because I'm gonna answer them. You're gonna understand.
oh yeah.
You're gonna understand the system if you just listen. And we'll never ever get this done if you ask questions in the middle, because it'll cause like a collateral calismic problem.
Okay.
Because then I'll have to remember where I was and stuff. And
Sure.
then, but I'm more than willing to. So if we were smart, you would have a questions sheet if you, or else you can remember them. But that's the only way it can work. But okay, so now we're gonna start with the smallest. Now every once in a while I'm gonna like a computer does loading, every once in a while I'm gonna have to do loading, but especially in the beginning. So we're gonna start, and we might skip around. I might start like this, and then I might say actually scratch that or hold that thought, and then I might come back to that later, but it'll all make sense though. So just to get the wheels turning, because I don't have my starting point memorized, we'll say life on Earth would be a good place to start. Or no, let's go back and start. Okay, so let's just do it from Earth. So you've got Earth. Well, we'll do that, because then we've got the moon, and then we're gonna, so here's Earth, here's moon, and now, let's say, how you get, it's kind of a big circle, that's why it's hard to find a drop-in point. So, the moon is now when you have, now keep in mind a bubble underwater, like when you have air above water, it's just air, and then when the air goes below the surface, it is instantly forced into a circle, because the water is, on all sides of it, is even pressure, and the water is stronger than the air, so it molds the air down. The only shape you can get when you have pressure from all sides is a circle. And so now imagine whenever you have, okay, a supernova is, we'll come back to that eventually, but a supernova is when a star explodes, and when it explodes, it sends its matter in every direction at high velocity, and so now these become little asteroids, little pebbles of a sun that burst, and they're flying fast in every direction, and that's why there's asteroids weaving through the whole system all the time, every which way. And so these things, these are the first building block of the solar system. Now keep in mind, no one's ever told me a single one of any of this. This whole thing is my creation, and it's obviously the only possible. You'll see. Okay, so you've got supernova explodes these things, and they fly out, and then those things are going like 30,000 miles an hour. But then imagine as they go through, imagine Earth and the moon, every gravitational item is sucking on every part all the time. So like every single planet in the whole system is affecting the path of this asteroid. It's just the more distance it is, the less impact it has. So when you watch an asteroid fly through the solar system, it's gonna move like a golf ball does on a putting green. Every time you have a gravity source, that's like a downward slope for the putt. It's exactly the same thing. Exactly. That's how we like when we shoot space shuttles. It's putting. We have to putt them, because we watch it go towards, like it goes towards Earth, and then it goes towards Jupiter, and we have to make it so that it's going fast enough, like to shoot through here. You have to go a certain rate of speed, or else you'll go like this, and you'll turn this way, and you'll get stuck in Earth's orbit, and eventually crash down and onto Earth. But if you go just fast enough, you break out of that, because over here you have Mars or Jupiter's pull. And if you just get past, it's like if you just get up over the hill, now you're falling down another hill towards that. So you can't go back to Earth now because now you're going downhill to Jupiter. So now, but you have to make sure that you're off Jupiter's path just enough now that you miss it. And so we do this on purpose because we don't have enough fuel on our rocket ships. We send them out and we have, on purpose, we have them go like this. Say we want to go over here, then we'll have just enough, we calculate just enough speed to make that golf ball, it would come from like an angle like this. The golf ball starts going towards the Earth, and it'll get a really close flyby, and then but as it's getting closer to Earth, it's gaining speed at a miraculous rate because it's falling out of the sky now. So you know what I mean? Like a skydiver accelerating. So it was just cruising out here at a cool 30K, but then once it starts turning towards Earth, it starts rapidly accelerating. So that causes it to have a near miss with Earth and slingshot. But now it's going so fucking fast that Earth's gravity can't hold it, but Earth's gravity created its speed. So then we do that's how we get our spaceship to accelerate without any gas. And then it'll do that off the next planet, and off the next planet, and it's like a serpentine belt. And it's like we putt a hole in one on a fucking really long putt when we land our spaceship on another place. And so that's no good. I mean, we got to get better than that. That's not going to work very long. That's hard as fuck to calculate. But so now you've got asteroids flying through the system at 25,000 miles an hour. And think about it. I've got them coming from a supernova over here, and a supernova over here, and supernova way over here. So they're coming in every which direction at all different rates of speed. Because think about it. Let's say there's Jupiter right here and Earth right here, and you have one. You could essentially have one go and get stuck right on the peak, and then everything is possible. It's like putting. So you could have it go like it's just literally magnets and gravity or balls and hills. And so you have them all different rates of speeds, all different sizes because it's random from explosion, and all different directions, and everything's all random. So they're just everywhere, and they're all flying and moving, and they can't ever stop moving until they hit a ground. And they still didn't stop moving. Now they're just moving with the ground. Think about it. Earth is still moving from from the supernova's energy that it had in each little pebble. Because that pebble cannot stop moving because there's no wind in space. There's no resistance. So it never slows down unless the only thing that speed it up and slow it down is gravitational pulls. And so now, as you've got this pebble that was going like this, and you've got this one that was going like this, and then this one starts doing this, and this one starts doing this because of Earth. You can imagine how eventually you're going to have two run into each other because of that, right? And so that's where when you have two asteroids run into each other, granted, it's going to be, sometimes it's going to be like one stopping and another one coming in hot and running into it at the top of a hill, or like one falling down backward while another one's going to escape that planet and they hit, or else you're going to have them coming in like that and hitting each other. You're going to have all sorts, or just a plain random one out here because they were crisscross crashed, like from their supernova. But they're gonna hit all different types of ways. Now, every time an asteroid hits an asteroid, you get a glowing spot from the impact has so much friction from the two rock surfaces meeting that there's a glowing spot on each rock and a big debris field that comes off of it. But however, you're left with a pulverized bunch of dust, which is now baby asteroids to be Earth dust to keep moving because it can't stop unless it stops on a hill and falls backward. It's going to keep moving till it finds its place to land. But the one left behind is now bigger than both of them combined are smaller individually. So now we have one bigger rock, but we have more dust. And so then when that bigger rock runs into another asteroid, it gets to be a bigger rock yet and takes out those two. But every time you run into two, one of them becomes bigger and one of them, the rest is gone. So it's only a little bit bigger because it's not a very efficient process to shoot two bowling balls together and then see if one's bigger. But it is. because of the glowing factor. Because the glowing factor, it melts the rock, all the rock turns to molten right there, and so it all sticks to it. It wouldn't work if we did this in a little small scale test. It wouldn't work because the rocks wouldn't glow and the pieces would all shoot off and the rock would be burst. But if we could get them to hit so hard that they boom, when they landed on the ground, they were both orange on like 1/3 of the rock, and we watched it slowly cool down. Then like a popcorn kernel, it would have a bunch of stuff stuck to the orange side because it fused and welded itself. So it got big. That's how the planets grow. That's how. Now keep in mind that whenever a bubble would go underwater, it would start off oblong and like when it get close, and then it would fucking pop to a circle, once the water pressure had taken its toll. But it came in at whatever random shape it got whipped into the water by. Like you could take your hand and go and see all the little different shapes, but then they would all turn to round bubbles if you watched it. And so asteroids are jagged shapes of just whatever. Asteroids are fragments of an explosion, and they're whatever shape they want to be. And then however, as those asteroids combine and grow, so you are still an asteroid. So you start off like this, then you go like this, then you go like this. Those are all still asteroids, and then asteroid, moon. Now think about it. When you're this big of an asteroid, and you're adding more asteroid to it. Every time you add more asteroid to it, you are pushing away more space. You're displacing more space. This thing's getting bigger and bigger every time it adds some to it, and so it's stretching the void in the sky open bigger and bigger and bigger. It's having more water weight on the back of the air bubble. So I can push a jagged piece of rock in this size and take up this much space, and it stays jagged. But if I put too much, as I pump matter into that spot, it begins to begins to have so much pressure on the surface because of the space it's pushing out of the way, that the space eventually pushes it into a bubble. And so like or imagine it like this. You can imagine it one of two ways. You can imagine the jagged thing is pushed into the shape of a bubble, or you can imagine it that it just adds material in a way that populates the bubble. You know what I mean? Mm-hmm. So but as it's inevitable that, because now think about it, Earth, water is more dense than air, so the air is literally molded by the density of the water and makes the round bubble. We're doing that same thing with rock here. That's how much force we're talking. So as the asteroids grow bigger, the definition of a moon starts the moment it's fully round. That means it has enough mass in it that it has enough mass that it's bending its rocks into a circle, because there's too much pressure on all sides of it. Now, this little thing doesn't have enough pressure on all sides of it because it's not taking up enough space. So it's like imagine if we were to like put a little tiny, like a Easter egg sized thing under the ocean and have you hold it. Let's see. And then let's put a Olympic stadium underneath the ocean and have you hold back that much ocean. Like if you were the beam in the middle that holds up we'll have you hold up a 2-person tent or the Empire State Building size tent. The ocean would crush the Empire, you wouldn't be able to hold back all that ocean. Sure. So this thing is just a little tent. Imagine it, now water and air are the same thing except for densities. So you can imagine water and air as the same thing, only water is more dense. And you could also imagine gravity as organization of densities. What gravity is doing is gravity is pushing everything towards the center of the gravitational object. Whatever has gravity, it's putting everything to the center, and so naturally, the like carbon and the denser materials get pulled on the hardest by gravity because gravity determines by mass, and so like styrofoam falls really slow because gravity's pulling on it really lightly, and carbon will fall really fast because gravity's pulling on it really hard. So carbon is also going to burrow its way towards the center of the earth over time. As earth shakes and does its thing and does the whole shake and bake, carbon's going to be working its way towards the center. The center is Earth's densest materials, and the denser materials are always working its way there, and the lighter ones are always working their way up. And then so you all of Earth is organization of densities, and so that's why water goes to here, and then air is above that, and because and they're not mixed because they're all of water is more dense and all of air is less dense. So gravity has slowly divided, like all the water fell down to the bottom of the basin, and then the air went above it. But that's because of densities. So the water and air is not different like we think. It's just different densities, but it's basically the same material. It's just different densities. And as far as we need it to be for understanding this, like, have you ever seen the birds that fly underwater?
No.
Okay, well, there's birds.
Like they go get the fish, or
yeah, there's birds that are just as good. They swim like seals, and like fish. They're just as good at swimming as they are at flying. They can fly, walk, and swim, and so they're really lucky. But so those birds make it perfectly clear that water and air should only be considered different in density. And so, let's see. So once you get to be round, you are a moon. And the very same time that an asteroid does not have its own gravity. An asteroid is not sucking other asteroids into it. They have to just happen to collide. And then you don't have your own gravity until you have became a bubble, until you're round. And so that's the magic number. That's when you become a unit. And that's when, so when I'm trying to, so better yet, imagine, so remember, imagine space as like air, only less dense than air, and then the planet is growing and pushing space away, just like air bubble does the water. And as the asteroid's getting bigger and it's pushing space back, it has to hold that space back now, or it would come in on it, And eventually it's so much that it can't hold it anymore, and it pops it into a bubble, because because it takes a certain amount of psi to move rock, and now the surface tension reached that magic number. So instantly you become a bubble then. So to me it's unknown if you slowly populate, like if you fill in the void, like maybe the rock hits over here, the asteroid, but maybe it squirts up over here. I don't know if they you know what I mean? It probably populates somewhat in the shape of a bubble as it grows bigger, or it might not. It might just stay oblong until it hits that magic number and then go boom, Yeah. Either way, it doesn't matter. No one knows that, but like I said, and I'm not going to ask anyone because this is all my own original thought, completely, entirely. We're just getting going. But so once you become a moon, once you become round, you're officially an astronomical unit. You're not an asteroid. You're not a rock. You're a moon. And now you're a moon that also has its own gravity. So what does that mean? Now it's like starting to put bids in on jobs. Now the asteroids that we're gonna now. So remember, the name of the game is running into asteroids. That's still the name of the game for the moon. However, now the asteroids slightly steer towards it, because now it has its own suction. So now it has a actual protocol for, like, an actual hope for living and growing. Before it was hopeless. Like this is like more like humans, and this is more like amoebas starting in puddles, on Earth. So now that's how you get a moon. Now keep in mind, a moon is going to keep Now, a moon is going to keep growing because it's going to keep sucking the things in. And however, one quick thing we need to get over is once you become a moon or become round, you also have your own gravity. And when you have your own gravity is when you get your own electromagnetosphere around you. Well, not necessarily. At some point, okay, once you get more to planethood, you get that. I think so a moon doesn't have a glowing center. Moon just has a warm center. Once you're a planet and you have a glowing center, that's the glowing center is when the electromagnetosphere comes. And, the gravity comes when you get the round moon, but the glowing center is when you get the electromagnetosphere. And now I'll say what that is in a second, but the glowing center is, nuclear fusion. So just like I said, at a certain psi, the surface will crush into a bubble. At a certain psi, the rocks in the center will the space between the particles will collapse. Did we already talk about that?
Well, a little bit.
So because there's a space between all particles, and once they can't hold the weight back anymore, and they fall in on each other and they collide, then it's called nuclear fusion. And then the byproduct of nuclear fusion is intense heat and light. So no fire, just heat and light, because you can't have fire without oxygen. There's no oxygen in the center because it's organization of densities, and oxygen's all the way out here. Remember? It can't be in there. It will just seep its way out, because that's the wrong direction for gravity to put it. Gravity has this thing layered like by densities. And so I like to consider those the cabinets in the kitchen, the ingredients, the vegetable oil, the eggs, the milk. That's Earth's ingredients are stacked in the cabinets based on density, and you can't change that, and you can do anything you want with them. That's why there is no such thing as pollution or any of that. There really isn't. It's all bullshit. It's all science. It's all political bullshit, because Earth, no matter what you do, no matter how you do it, no matter what you take from it, we don't harvest space yet, and if we did, it wouldn't matter. But we only harvest Earth, so everything we take is from the ground, because nothing floats besides gases, and so everything we take is ground born, and unless we're talking about gases, but whatever. And when we get, however you modify it, use it, burn it up, none of the materials of Earth change. They combine in different ways, but they always break back down. Like when you take nutrients and turn them into a tree by growing wood tree and then cutting them down and then building a shed, and then 30 years later burning the wood when you're done with the shed, and that wood you think now went to nothing, it went back to the exact same nutrients it started.
Yeah.
Earth starts off as like 125 different elements, and you use how many of them to build the wood, and then we'll just say 64, and then when you burned the wood, it divided it back up into 64 elements of dust in the form of dust, and it went in the smoke, most of it. And if you were able to capture all the smoke from 100 pounds of wood and weigh it, that smoke would weigh damn near 100 pounds. And so Earth didn't lose anything. That wood is still here. It just divided back up and sent out for gravity to fucking organize it. And there's nothing you can do about that. And water ensures that it's going to happen. Yep. Water, wind, and all that, tide, high, low tide, all that's going to make it so that Earth files it back away quickly into its cabinet. And you can't stop it from doing that. There's nothing you can do to stop it. If it's light, it's going to go for, I don't care if it takes years. Earth doesn't either. It'll put it back up here eventually. And there's nothing we have to worry about. We cannot do anything to keep gravity from doing this. And so now the electromagnetosphere, what it is once the center, let's just say it's like 2 trillion psi, and all of a sudden the rocks turn on, they light up. Before that they weren't lit up. As soon as they light up, it's like imagine like a reflection on the outside from it. Magically on the inside you get another layer of invisible force field, and that is actually an electromagnetic field, and it does wonders for you, because what it does is now Earth has volcanoes. Remember, this air out here, space air, is very thin, so thin that if we fly 1,000,000 miles an hour in it, we don't even feel any wind. Just like imagine if you're going 100 miles an hour in water and you stick your hand out, it's like it pulls your arm off. Then you're going 100 miles an hour in air, and it's like more manageable because the density is different. Then you go out to space, and 100 miles an hour, you can't even feel it. And but that's what's unbelievable is that space is thick enough water to mold the moon into a round thing. So it is, but it's so thin that we can't even feel it. But the moon is so big that it still molded it into a bubble. And so when it seemingly we're pushing nothing out of the way, we're pushing so much of it that it is something. And I'll keep in mind that nothing I say, this is all original and unproven yet, but I guarantee you I'm going to go down as right. If I ever write this book, it's going to be legendary because it's going to be the first time that the whole, from the start to the finish, is explained and understandably. And I am the world's leading, probably the world's leading elementary explainer of this. And I'm not kidding. And I will write this book eventually. That's why I need to start doing that every time I teach someone anything so that I don't have to keep doing it.
Yeah.
And okay, so now we're gonna cover everything, but it's only probably gonna take 2 hours total. Let's see, magnosphere. So now we have volcanoes, which volcanoes are just probably like you've got the nuclear fusion in the center, but then you've got you've got densities like imagine when there was like a huge collision at some point in the time where we gained a bunch of material over here that was like the wrong density for its location, and so now it's like acid indigestion. It's like there's a big clump of earth that's trying to go down and then up, and like you get messed up, and you pop into like you pop through, you get close to the you have like the earth get close to the hot spot, but that's because the hot spot is the hot spot's shifting around and stuff, and like bloop bloop bloop, it's having a really rough lava lamp transition of materials, and then it cracks through to the surface, and you get a volcano, and so basically like acid reflux or excessive pressure in the center with excessively what's not dense? What's the opposite of dense? Thin. Too thin of a material gets too hot and it makes its way to the surface. Yeah. Because it's not dense enough to stay down there, but it got hot because it unfortunately has been down there. So like water boiling in a deep fat fryer, you throw some water in it, it fucking freaks out, that's like we're having some stuff freak out and go make a volcano to get out of there, steam its way out. Now when that volcano blows off, imagine the electromagnetic atmosphere as a plastic bag. It's something that you can fly through it and break through it, and you actually popped a little hole in it, and a little bit of negligible loss occurred with you, but you've escaped it now, and it closed right in behind you like a bubble that you can't pop. And so now this area is where all wind that we know it exists, and all air exists. And what is that air? It's a 14.4 psi in a balloon. It's a balloon blown up to 14.4 psi of volcanic output. And the volcano is blowing it up to a pressurized state. All of them are. And so volcanoes are literally what make the air that we breathe. And the air is not actually anything. Air is just pressure. And so now without air and without pressure, there would be nothing, because so just imagine pressure is the same thing as saying thickness. So it's a whole bunch of this stuff out here all jammed in there. And so because of the rocks, when you burn off the rocks, they if you want to have this big of a rock, or you want to have it as burnt rock smoke vapor, it's that much burnt rock smoke vapor. So we had so much to start with, and then we trapped it in, and now we start cashing it in for bigger air. and so now it's filling this up, and so this pressure is always going up, but we are always adapting to the higher pressure, and I mean, we will grow with it. So out here in space, this is 0.0 psi, even though it has a pressure. That's what we set it to. We took a gauge and we made a pressure gauge. So basically, a spring that gets pushed on and by atmospheric pressure. And you're gonna think if you're like just some dumb idiot that doesn't understand anything, you're gonna think it's at zero no matter where you go, because it's gonna just be the spring. Like if I set it on the table, or I put it like it's not. I could take my finger and push it down more. So I'd be like, it's not, this is the spring starting spot. Well, Earth has pushed it to that starting spot. Earth is buckling it. Me and you are fighting against the 14 psi. We're used to it. That's why, that's why we can do that, because we're fighting against it. We're just trained. We're used to it. We don't feel it. So that's why it was just like I had to fight. I had to try to get up. Everything is we're against that. In space, there isn't any. And so we took we made a pressure meter and took it into space, and okay, imagine we had a pressure meter. It had no numbers on it. We didn't know what psi was, but someone made this thing that gauged it, pressure, and the fucking spring would be like as you would climb mountains. So look, as you go this way, pressure decreases. As you go up, there's less and less and less and less, because that's like this. Imagine this is water, because air and water is the same thing. So here, standing on the surface of the Earth, we're on the bottom of the ocean, and it's heavy as fuck. And as we go up and up and up, there's less and less water on top of us, which is air though. And so by the time we get right up here, there's almost nothing on top of us. So there's almost no pressure. So the pressure is of 14.4 is on the surface, and so when we flew out to space and we saw that this is where the meter was in space, and this is where it was on Earth, we just said 0 for space. We calibrated the gauge to that, and then we just said -20 over here, and then we said 100 for the end of the chart, and then we measured. So we're like, okay, we have the chart now. It's 0 to 100. We just made that up from scratch. So now space is 0 and Earth is right here, and the meter goes to where humans had the test set with no numbers on it. The end of that we called 100, and then we just had to measure. So this is 3/4 of the way to 100. So Earth is 75 units. I mean, it's actually 14, but this is just representative. So let's do it right then. So Earth was right here, space was right here. No, let's leave it where it was. Let's just say this was 20, not 100, because 100 is too many. So we said 20. So 0 to 20 is our little pressure sensor that we just created, and we go to space. Well, it went farther than that, but when space only went to here, so we called that 0. Because we want space to be 0. Then Earth went to here, so that's that. But 20 is what we want the gauge to go to, because we see Earth went here, and we put it there, and then we measure, and it's 14.4. So that's how you come up with all forces that we measure with. You just find a way to modulate the differences between two places, and then just put numbers on them, and then anything in between, you just calculate the distance it is, and the percentage it is in between. But okay, so now this is when we breathe, we live off oxygen, not off air. The reason we need air is because there's a medium that connects things and moves things, and when you suck in air, it comes in like a conveyor belt that has oxygen on it, and the oxygen itself is not the pressure that is in Earth's atmosphere. It is the air, and the air is so it's a siphon effect. If I suck this air in right here, it moves this air over here, and then I suck that air in, and it's a conveyor belt or a siphon effect. And if you go out to space and you suck in, there's no air, and so nothing moves. So when you go, you suck in, you don't actually. It's not. There's no tablecloth with the dishes on it pulling you in the food. So there's oxygen in out here, but when you suck in, it doesn't move towards you because there's no medium to move it. Just the same thing, like when your ears are just vibrations, sensors. They hear vibrations in the air. That's all sounds are. Is anytime you have like that, the air that was between the collision just vibrated, and so if you go into space where there's no air pressure, and I do that, it doesn't vibrate any air, so it doesn't, your ear sensor doesn't hear it, because your ears don't actually hear sounds, because that still would have made a sound in space, but it couldn't travel it to you. And so just like you can't get shocked if the electric wire doesn't come to you, and so you can't receive the sound. So this air is all of your, this is the vehicle that brings all of your gas that you need to survive into you and away from you, and into the plant and away from the plant. And without that, it doesn't move, so it's impossible. And then now it also is the connection for the sound and the hearing. And so now the last thing it does is electromagnetosphere. It actually makes you your own dimension. When you, so you've got all this space here, and that's not a planet, that's space. And then so you want to fly across this open area in a straight line. Okay, now let's do it again. Let's put an Earth in the middle of this space that has an electromagnetosphere. Now, when you want to fly through this in a straight line, your spaceship is going to curve around Earth like that. However, you did not steer, and that is a new straight line. You do not so when you took Earth and put it into this space, it before it has its own electromagnetosphere, it's pushing against this space, and it's occupying it, and you can get ran right at the fuck into. So like the moon, that's why the moon has all those craters, because it can get run right the fuck into. Earth is almost impossible to hit. That's why we don't get hit with big asteroids, or we'd all be dead. Dinosaurs did maybe once after 1 billion years, because every asteroid that comes in virtually is impossible to hit us, because a straight line is missing us. So this vessel had no G-forces to go this way and none to come back this way. It flew straight, and so imagine it like when you look at like orbs and things are like around the orb. It's literally, it goes around the orb like and it doesn't hit it. It's called its own dimension. So what's really confusing though about that is the day that you grow an electromagnetosphere is the day that you become a straight line avoids you, which is also, now get this, remember when you were a moon, you were pushing all of the space away, and that's why you popped around. However, once you get an electromagnetosphere, I believe you birth new real estate that does not interfere with the other one. So this one stays the same. The day that you get the electromagnetosphere, you're no longer pushing all of that out of the way. You boing, you become, all of a sudden you go through each other. You don't exist in the same realm anymore. And but that's really confusing, because that, in some understandings, would be the day that you supernova, the day you burst, the day all of your materials puke back out, because the space is what's holding it in the bubble. That's what's pushing it into that bubble. So because I don't understand how the electromagnetosphere why was, hold on, why was I thinking that? Okay, that was a good thought. The electromagnetosphere, I feel like you lose I feel like the pressure that on the backside that holds you together dissipates, and now the electromagnetosphere holds you together like a steel cage. You know, like the duties flip, and then it relieves the pressure of the surrounding space, but only temporarily. And why do I know that? Why did I just had a deep connection of an epiphany that made me just realize that. And it was, let's see, what was it? It was, okay, the electromagnetosphere pops up, and then now it's a curved line to go around you. So what's interesting is, well, it's still a moon, and it's not big enough yet to have an electromagnetosphere, so it's not big enough yet to have air, so it's not big enough yet to have life. It wants to get hit by asteroids at a high level. It wants to grow more, so it has no shield. And then the moment it becomes big enough to be an Earth, it steers them all around it. So it wants to harbor life for a long time because it itself is life. This is obviously what I'm explaining is birth and growing and aging and then death. And we'll get to death. But so I just want to remember why I had just realized that there's some sort of anomaly I just noticed about. Okay, it had something to do with the steering around it as a straight line. Why would that be? What? Oh my gosh, what was it? Holy shit. Okay, so why would it drop the why did I know that? Why I was so connected to it a second ago that I knew that would be what happened, but now I can't remember why. Do you have a cigarette?
Yeah.
I can't remember why that happened. I need to smoke a cigarette and have a moment of silence and try to remember why that would happen. Let's see. Okay, so the day I get my center to be glowing is the day the reflection on the outside pops up in the orb shape of, and then moving space out of the way. No longer does it need to do that because now this electromagnetosphere keeps it. Why did I know that? See, that's what I wish I could just pause the tape and go back and listen to myself, but I can't until I'm done.
Yeah.
You know.
You run some kind of magnetic transformer type of thing.
Let's
but
see.
I'm a little lost there too.
No, you're not. You're not actually
I
lost.
mean, I'm just saying that's where you kind of.
But okay, I mean, you're not lost because you've got gravity is organization of densities. You've got air, you've got water, you've got rock. Gravity is going to keep, and then gases out, and electromagnetosphere is a bag that holds it all together. You know what all this is now, if you think about it. So you got rock, water, air, gas, the bag. Gravity is going to keep it like that no matter what. And as it gets bigger, the rock's always going to be in the middle. As it gets bigger, the rock gets more and more friction on it, more and more pressure, more and more weight. There's a magic number, like 20 trillion PSI, where that fucking rock bursts into light. Just like, and that would happen right here on this table. If we could take two rocks and crush them together harder and harder and harder until we hit that, whatever the number is, they would turn orange. And when two asteroids collide at 30,000, for a moment, they reach that number. And so they turn orange in that spot. They only hit that 20 trillion right in the impact point. And that's where they fuse together. And so now all my numbers are fake, like my 20 trillion and stuff. That doesn't matter.
Oh, really? Okay.
Well, no, I mean, why would that matter?
Wouldn't matter, I guess.
Yeah, because that's just to say, I'm explaining how this all happens, but the numbers don't matter.
Yeah, okay.
Because they never really will. When you see the two rocks hit together and the glow, and then you see the fusion, and then you see the planet grow, and now it's just obvious that it's the rocks can only handle so much pressure. It's going to be this. Each rock is going to have its own pressure to where a threshold to where nuclear fusions, and each planet or each unit is going to have a different combination of rocks at its center, so it's going to be a different hybrid number. So every planet is going to have a different number of pressure that it takes to make its rocks ignite. And now, as the planet gets bigger, so now let's do that. Let's say that that's good enough for elementary physics of the starting point. Now let's move on to that fundamental operation of it, like this. Oh, and it's important to realize that remember that the electromagnetosphere causes a straight line to go around us. So now asteroids are most likely going to miss us. They're most likely going to hit the moon, and they can come straight into the moon and hit it head on, like shot out of a gun. Bullseye, boom. You can't shoot the Earth like a bullseye. If you hit the bullseye with the Earth, it goes shoom around it. So to hit Earth with an asteroid is almost an anomaly. It's very difficult. It requires the gravitational pull of Earth and some sort of hiccup of a path, like remember the golf ball coming in. You have to have some crazy, like imagine if the golf ball slingshots around this one and then around it gets on this wild wacko path, and then Earth's gravitational pull does it in. It has to lose control. Imagine a car spinning out, and wrecking. You have to have, otherwise everything that comes into Earth like normal, everything that's like, we're on the Earthbound Express, we should land at 217, everything's looking good. That fucker zoom, misses it every time. The normal ones miss us every time. And because it's impossible that they hit us. So it's a unbelievable occurrence when they do. But every once in a while, one will find a way to get through that. Because it's not impossible to get through it. It's just takes a lot more force. So, but however, remember, Earth is still pulling on every single asteroid. So it's pulling them all in, but it's most likely going to put them on the railroad of the normal track, and they're going to do that. They're going to come in and do that. They're going to come in and do that. And they're going to come in and do that. And that asteroid did not turn. That's what the beauty of it. That's why we're so safe here. That's why we really don't have to worry. Once you understand the way this is living, just like we are, and you realize that you don't have to worry about anything that they want you to until death. And death is nowhere near. And so we're not worried about nothing. And Earth is not, there's nothing that you can do to stop it or hurt it at all. At all. No matter what. You could try your best. The government could try its best to ruin the Earth. They can't do it. They can't. No way in hell. I don't care if they put big things out in the ocean. I don't care what they do. Those things are tiny compared to Earth. And once we've had our fun, Earth will promptly put them back in the cabinets. And it doesn't fucking matter. And there's nothing we can do to stop it. We could take as much of this as we want and put it down here and it will just bubble its way back up to there. There's nothing we can fucking do to stop it, and it'll start working on it immediately, and it'll just steady. Gravity will just move the bubbles forever, steady, and no worries. And if you go out to your yard and try to kill a spot of the yard, just because they say we could hurt Earth, if you dump like 5 gallons of gasoline in your garden, those plants won't come back for like 2 years, or maybe tops, like maybe a year. But after 12 whole months, if I come plant, I don't care what poison you put on the ground, in a year, I can plant stuff there and it grows. So you can't permanently kill 1 unit of Earth. So how would anyone believe that you're killing the Earth when you can't even prove it in 1 square foot? Give me a dead square foot of Earth. There isn't one. Every square foot of Earth can grow. And if you temporarily, imagine if I dump a bunch of oil in the yard right here. If you come back in a year, it's going to look like dirt. The oil is going to be back in the cabinet, and so like when you can dump antifreeze like this. What's funny because one time these people were arguing with me because they had a bunch of antifreeze they need to get rid of, and they're like, "What do you do with it?" And I'm like, "What do you mean? What do you do with it?" And they're like, "You have to call like hazardous material." I'm like, "You dump it down the drain," and they're like, "No, that's so illegal." And I'm like, "How is that so illegal?" And they're like, "You should know this. You're a mechanic." And I'm like, "I'm an astronomer, and that's why I know this." I'm like, "When you dump it down the drain," they're like, "You'll kill fish." And I'm like, "Are you fucking stupid?" Because all the materials came out of the Earth that we mixed together, and now they're poisonous. But they were all over the Earth to begin with. And so they're only poisonous in this combination. As soon as you dump them down the drain, they start diluting at the moment they go through every body of water and every drainage tube. So they're in the concentration level to kill one fish the first like 20 feet in the tube. And once they're 20 feet down the fucking drainage tube, they're no longer constant. It's like super diluted lemonade now. You can hardly taste the lemonade. A fish might get a fucking eye ache or something, and then or get like a spot on him, and then but he's fine. And that was like one fish, not like millions. And then now that can't even happen anymore. And now as this shit goes downstream, it gets more and more and more diluted, and until it's eventually all the building blocks spaced out again, and then they get stuck under rocks or stuck in their fucking cabinet. And then that's that. But now to go back to what I was going to do next now about the fundamental operation. Okay, so you've got, now you know how it becomes a moon, and now a moon is still moving at the speed that it was shot. All the particles were shot by the supernova, and so the moon's flying through there. It's a rogue moon right now, and now you have here you have a moon that's farther down the line, so it's actually a planet, but no planet is a planet yet. It's still a moon, even if the center is glowing and it's still flying randomly through space, you know, like on its fucking putting path, then it's still a moon. And then now you've got a new thing we haven't talked about yet: stars. And a star, now as the planet, so here's a small planet, here's a big planet. As the planet gets bigger, remember you have to get to 20 trillion psi to light up your rocks. Well, 20 trillion psi is going to be closer. But as you put more weight on your planet, every day that goes by that you get more millions of pounds of asteroids and dust, your planet gets bigger and bigger and bigger. Well, guess what? At the same rate, the center, the glowing center, gets bigger and bigger and bigger, because the 20 trillion mark is growing. You know, it's as you put more weight here, now it's you don't have to go as deep here to hit your 20 trillion pounds, because I just put another 2 trillion pounds up here. So yesterday here was where 20 trillion hit, but today I got 10 trillion more pounds. So now the line's moved up to here, because I'm packing so much in there that the 20 trillion is growing. Now because just like in all things in life, like to get 130 decibels out of a stereo is pretty easy, but then to get 140, it takes like triple the power it took to get to 130, and then to get to 150, it's like quadruple the power, you know? Like, it becomes very difficult to push beyond these thresholds. So, Earth size thing takes a rock in, give Earth a big rock, and Earth gets a good size bigger. Give Jupiter a good size rock, and it doesn't change in size, it just gets tighter. It just becomes a tighter filled ball, because space says, you know what, fuck you, bud, I've moved enough. You know, and space becomes that 150 decibel mark, and it doesn't want to go anymore. And so now that makes it so you can just start putting the shit away and putting the shit away. And so this thing, once you start doing that, once you start Jupitering, once you run out of ability to put more space in you and get bigger, and you just keep putting stuff in and staying the same size, but your total mass is increasing and the tightness of your balloon is blowing up tighter, and now this center is getting bigger. Every time I put more in, my glowing center gets bigger. Eventually, surface resistance becomes so tight, space is that tight, that it won't budge anymore. You're as big as it wants to get, and you keep for millions more years packing it in there. Eventually, you hit your 20 trillion on your surface, and you're a star. And so now a star is so naturally that's why stars have to be big. They have to be. A star is the epitome of what a planet can't. You can't. You know, a planet can be as big as until it's a star. And now, but you're not a planet. You're still a moon until you get in this arrangement here. So here's a star now, and now stars are the actual hills in the putting green that we were talking about before. Those are the strong ones. So your asteroids flying here getting sucked in. Well, you're getting sucked down in by planets a little bit, because planets right there. But then you're getting sucked in by stars a big bit. So the stars eat most of the food, you know, and because they're sucking so much harder, and the little planets get just a little bit, and these stars suck in all the fucking dust that goes by. and also, I don't know if they have an electromagnetosphere. I think that it's probably like at their surface. I don't think it's out here. I think they are back to feed me zone because there's no life there. I swear it's designed around life. It harbors it with the electromagnetosphere only in the time that it would have it. And so all these things, now these things that it took me many, many years of deep thought and this shit might seem impossible for me to know. It didn't come overnight, and I'm way more advanced than anybody knows because nobody can handle me. And I am that 99.998, and that's why I don't fucking argue with myself. I don't doubt myself, and I'm never wrong. But I can't help that. And people think that means I'm cocky. It doesn't. It means I'm 99.998. It's like, I'm sorry. I mean, you want me to lie because the cool thing about it is I don't have to because I can also beat your ass, motherfucker. Like, so I'm literally the Charles Darwin that can whoop your ass. And I think in that situation, I'm probably the only one of all time. Like, I'm the only philosopher that can also, I think I can beat up, 99 point maybe 899% of people, and to be like that, and like that, we're talking just physicality and mentality. Like, holy shit, I deserve a lot of respect in reality. If those two are true, combine the two, total human number like 99.972, like some shit 9972 or something, like shame on the motherfucker that doesn't listen to me. That's what I have to live with, that knowledge of knowing that, but only very few can receive that and understand it. I don't say that with any sort of bad feeling, negativity. I have no hatred for the other man. I basically pity him for not knowing who he's fucking with. And I can't help it. I know that I used to think I was like 1 in 1,000, because I would look at my school and I'd be like, oh, there's probably 2 of me. And then I realized that I'm 1 in 10,000. And I'm like, oh, there's like 4 of me in my town. And then I realized I was 1 in my town. And then I realized I was 1 in a million. And then that might be where it stops. And I'm like, I'm 1 in a million. And like, you go through a million people and you can get me a sidekick, another fucking, that leaves, out of every 100 people, there's 0.001 people. But then multiply that 100 people out to 6, 7, 8 billion that we're at, 8 billion population. What's 0.001 of 8 billion? All of a sudden, there's other me's out there. So I know that, but it's just not you or you or you or you. It's just not likely to be whoever's arguing with me. So now the Suns are pulling everything in, and because they're so big and they pull so hard, they're the steepest downhill for the golf ball. And now, to become a planet, let's show how a moon becomes a planet now. So the moon is just flying by. You can call it a rogue planet if you want. A planet, I'm gonna call it a planet if its center's glowing, or but it's gonna be, all of this is gonna be size based. It's gonna be like that if it's too small. It's gonna be round if it's a moon, and it's gonna have a hot center if it's bigger than a moon. And then here you've got the sun, and you've got this thing coming in doing its crazy golf putt, and there's a magic speed and a magic trajectory that you go at. So you're coming in so fast. If you're coming in too slow, it'll turn you in, and you'll hit the surface because it's pulling on you. It's pulling on your rope, and you have to be going so fast that the rope burns through its hands. And it pulls on the rope however hard. It's based on its mass. The more mass it has, the harder it pulls on its rope. And the more mass you have, the bigger you are, the more you get pulled. So if you come in too fast and at too steep of an angle, you'll just skate by it and shoot. It'll launch you out into speed, shoot you, like slingshot you away into space. You'll break out of its pull, and you'll only gain from the downhill slope towards it, and then you'll fly away like a dirt bike off a ramp. Or you'll run out of speed because you didn't come in fast enough, and it's like an uphill to get out of there, and and you fall in, or you do the spiral in, or you're going at just the right angle and just the right speed that you hit a miraculous. It turns you. It says, "Come on, come 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 on," and so you forever get trapped in this thing where you're falling, but you're not falling enough. And so, like this thing right here is not, we think of it as flying straight in orbit, but it's thinking ground. It's turning the whole time. The guy's holding the steering wheel all the way to the left, and it's just skidding, like on an ice ledge, and it can't slow down because it's outside of that. It's in the 0.0 psi, and so you stick your hand out the window. There's no wind, so it doesn't slow down, and so it keeps going. But Earth never quits pulling on it. Earth's sun never quits pulling on it to go down, but it's going too fast. It's like the penny at Hy-Vee in the thing, and it won't go down the hole. Imagine if there was no gravity or wind, it would never go down the hole. And so, but if you speed that penny up, like with an engine in it, it'll come back up and out and shoot out, And if you slow it down, it'll fall in. But if you hit just the right speed and maintain that speed forever, it'll go around forever. And so and all the speed that caused this to happen would be from the asteroid and the falling downhill on the way. And it's just a miraculous thing for it to come into just the right thing. So many times you'll have this guy just go into the sun, or you'll have this guy go into the sun, or this guy go into the sun. But when you get this guy and then you get him to fall into that magic around the sun, you get a planet in orbit of a star. And now that planet in orbit of that star, the same exact way, can pick up a moon. The moon can come plinkoing in and go boonk and hit that magic spot where it's going it can't slow down. And if it was going faster, it would spiral away. But it's going just the rate of speed that matches the amount of pull that this has. So you eventually could lose your moon if it gains mass faster than you, because then your rope gets too weak for holding it and it starts flying away from you. But you're going to grow most likely at the same rate as it, so you're going to keep it. And now, and you're obviously growing your way towards starhood as you're a planet. And obviously once you get more stars, they're going to tend to either one's going to be dead or they're going to collide. They're going to combine before it gets to be a star. Like imagine Earth is orbiting the sun, but we don't know how big the sun can get a lot bigger still, and we don't. So like let's say Earth's right here and the sun's right here. Like what happens when the sun's right here and Earth's bigger? Like eventually it's probably going to just be part of it, and so that won't even matter. It'll just be because when we look out, there's suns, the sun is tiny, our sun is tiny, and there's other suns that are like 5 million times the size, and we're talking 5 million times the footprint. Imagine how much more pressure is on the surface of that motherfucker, because remember, space doesn't even let you grow anymore hardly. So it's like to get 5 million times as big as our sun means you have 20 million times as much shit in it, because it's harder and harder and harder to do. And so who knows how many fucking Earths were consumed in the process of it growing that big. And then that doesn't matter. They're gone. They're just part of it. And then there's a new Earth now so when you have a super sun, imagine like our sun has an Earth right here. But once it's a super sun, the Earth is way out here, because now it pulls so hard that you got caught in gravity way out here. So you have a whole new fucking chart to look at and think about. But however, for many billions of years, Earth is going to be in a perfect relationship with the sun. And our sun has happened to pick up 9 different planets. And think about it. Each different planet is on a different path. And so it was a different mass and a different speed needed to achieve that orbit. Each one hit the magic number, If not, it's bye-bye. And the ones that get stuck hit the magic number. And then, it's like, boink! It's like, remember Mario Kart when you get the thing stuck on the front and you have to like, rah, 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 hop it off, like, boing! We're getting these things clinged on, Like this clings to the star and the moon clings to that. And the asteroid doesn't cling to nothing. Asteroids can get caught in orbit, but, and they do, and there's tons of asteroids orbiting the Earth, and so it's all just the same, just the same. They get plunk, hooked onto, and we like to call them like belts, like asteroid belts, and so that's all like future Earth food, one way or the other. It's probably not going to escape the orbit. It's either going to Earth's going to get a little bit bigger, and then the pull's going to get stronger, and it's going to start to spiral it in, because the asteroids are likely not going to grow at the rate Earth, because Earth has gravity. So Earth is going to eat those asteroids eventually. And that's a concern, but not really, because the atmosphere is where the 14 psi begins, and if the rock goes from space of 0 psi and hauling ass, and then runs into our fucking atmosphere, it's like all at once. It's like sticking your hand out the window at 30,000 miles an hour on the highway, and so your hand gets ripped off. So when it hits the fucking air, it burns the rock up, because the 30,000 are like, if you shoot a rock out of a cannon at 30,000 psi on Earth, it will disintegrate, because the wind is too much. Now, so also, like, let's see. And when an apple falls off a tree, when that apple's falling, it's weightless. If you have it'd be a little toy car with a little mouse in it. When you drop that car out of that tree, that mouse hovers in the middle of the car, and he doesn't hit the ground, and everything rises up slightly off the ground. Everything centers and hovers in free fall. And think about it: when a spaceship is in orbit, when we put a spaceship in orbit, we fly it up here and we put it on the line of our choice, and then we gun it to the speed of our choice. And we know once we hit that speed, we shut everything off, and it never slows down again. And we watch. If we go too fast, we watch it drift away. If we go too slow, we watch it drift down. But so we can turn the thrusters on every couple. Like satellites, satellite TV and shit. Those are out there with little thrusters on them, and satellites have fuel in them, and we have to refuel them. And they now why? Because they're probably in too low of an orbit, and so they're constantly being pulled down towards Earth just a little bit, which is maybe drag and maybe slows them down just a little bit, and so they have to speed back up to stay at that thing. But the spaceship. So it launches off of Earth, and then it spirals up higher and higher, and then once it gets out there, it just guns it until it hits that number it wants, and then it shuts off, and now it can orbit as long as it needs to before it wants to go home. And or it can gun it, go too fast, and sling out. And however, do you have a pipe? Is it gone?
No, I don't think there's shit.
So now, okay. So when when you see the gravity, when you see astronauts in a spaceship and they're floating around, and there's no gravity, what that is not no gravity. So that spaceship is dealing with the exact gravity. Does not go gravity. So gravity doesn't end. Like gravity from the Earth goes in every direction to the end of the system, which is forever. So gravity never ends. The reason you won't have much effect of Earth's gravity way over here is because you're closer to all the other gravities, so they're pulling you harder. But Earth's gravity right here is 1 of 1. Earth's gravity right here is 0.5 of 1. Of here, it's 0.2. Here, it's 0.1. Here, it's 0.05. You go all the way out there, and it's just a fraction of Earth's actual pull, because all the other ones diluted it, because they're pulling more. But it never ends. It just gets weaker and weaker and weaker. So when that spaceship is right here, it's still subject to, like, say, 99% of Earth's gravity. I'm going to say between... for lack of knowing, and numbers don't matter, I guarantee you it's between, I do this a lot, I don't know any specific numbers, but I have to really think based on my comparison and just relativity. I'm going to say between 85 and 99. I'm going to say, 99 point anything is 99. It could be 99.99999, but that's 99. It's somewhere between 85 and 99. I guarantee it's no less than that. So those guys, if a guy weighs 200 pounds on the ground, he would still weigh like 185 in that spaceship. He's not actually weightless. gravitation wise. His gravity is exactly the same. What he is though is he's free falling. He is not falling straight down, but he's trying to. He's falling straight, like his spaceship's right here, and it's falling straight down, and that's because he was going this way, but Earth's falling him. Earth's gravity is, so it's like, imagine it like this. Make it a square. Whoop, missed. Turn. Whoop, missed. Turn. Whoop, I missed. Whoop, I missed. Whoop, I missed. Whoop, I missed. He's trying to fall, so he's not orbiting. He's falling into the Earth. And just like this apple gets a linear fall, bonk, hits the ground, and his astronauts inside were weightless the whole way it was falling, and so they were floating. The mouse floats, the astronaut floats. He's not, his body. If your body doesn't have gravity, it would come apart. The electromagnetic energy that holds the particles together when they're not touching is the gravity. And so his body is perfectly healthy in this spaceship because he's getting full gravity. He's getting the same weightless effect that you feel when you jump off a cliff. And his cliff is just, your cliff that you jumped off of collided with the ground. His keeps missing it. And okay, so that's that. Now let's see. Okay, so let's go now to, so once you become a giant star and you're a star's nuclear fusion is a byproduct of the rocks that are inside of it at a certain pressure. Nuclear fusion only gives off light when a certain combination of elements is present. So let's, for sake of simplicity, let's say fuel would be a good term for that, right? If so, this as this thing is nuclear fusioning, it's changing some of its ingredients, some of its materials. Mm-hmm. Like, let's say it has like hydrogen in it, and it's turning it into nitrogen or something. So it's reorganizing its densities into a synthetic or a planet-made arrangement, you know, like where they say man's ruining Earth, well, sun's ruining sun, you know, and he's combining he's fusioning, he's burning up his fuel. Mm-hmm. And so granted, he gets so much new fuel every day in the form of new rocks falling, and that's the beauty. That's why it goes almost virtually forever. But there'll become a day where he gets so big that his nuclear fusion is so mighty that the asteroids can't keep up with fueling it, and it won't run out of mass. It'll stay the same size, but it will convert all of its fuel into used fuel. And the fuel, by fuel, I mean the whatever it is. So you can take a certain mix of ingredients over here and nuclear fusion them to all hell, and it doesn't glow. It just nuclear fusions without glowing, mm-hmm. And that's because it doesn't have fuel. And fuel, it could be anything. I don't care. I don't care what the specifics are. But you have to have the fuel for the nuclear fusion to grow. Now this is where I go way into my own creation. Because so this sun is now way too big for space to hold it in. You've put so much in there and it's pushing back. Space is like a balloon that is about to pop. And this fucking shit is about to burst out everywhere. This shit should be way bigger than it is. You've put way too much in there, like risky business. Don't get near that one. It's going to go. And because for the last 100 billion years, it hasn't even gotten any bigger. And you've been putting planets in it every day. And it won't get any bigger. And so you're like, it's getting tighter and tighter. And you just know something's going to happen soon. And what keeps it from blowing is actually the heat. Because remember, when things are glowing, they're glued. Like they're molten. When they're molten, they weld. This thing is. And remember, this fusion without fuel does not give off heat or light. So, but it's still technically fusions, I think. But I'm not sure about that. I think so though. So this one, when you have this one. fusioning with light and heat, and that space, the pressure of space, and the cohesion of the fusion, which is interesting. It's called nuclear fusion. So the particles are fused together. They're literally burned together and welded together. And so that is what keeps the star. The star is a very unsafe proposal because it cannot actually hold. It's a water balloon with so much water pressure inside of it because you put another little exoskeleton around the water balloon and it's just holding it. But it's like dipping it in Baskin Robbins chocolate for the ice cream. And then you're like, dude, it should not be holding this. And you just keep putting it in. It hasn't blown yet. And so, however, it has to be glowing to keep that in there. Now, I can tell you why. So, now the day that it stops glowing is going to be the day that its fuel consumption exceeds its asteroid intake. So in every time it gets bigger, it becomes more of a gas guzzler. It becomes more because its fusion becomes greater, and so it burns more gallons per day than the day before. So as long as it can keep finding food, it can keep doing this. But eventually, it's going to outgrow bigger. The rate it gets food can only go so much. Once it gets to be as maximum gravity and it's sucking in all the food that it can. Now, what if it grows another 100 billion years? There's always another, whenever you can't get any more food, then you grow more, then you're done. And so, then you have nuclear fusion go into a cold burn because it runs out of fuel. And so essentially, whenever it runs out of fuel, it cools very rapidly. This whole thing is molten glowing, and now it starts cooling down. The fire goes out. The heat from the core goes away. When that thing cools that fast, think about how much it shrinks because it's thermally expanded like no other. And when it cools, it goes shoo, and it starts shrinking so fast that it changes its size so drastically that it cracks everywhere as it's going. Like the rocks are just like crack because they're not flexible. Well, once those crack all over the place, and you lose the cohesion effect of the fusion, pow! It all comes back out, and you see that it was overloaded. And you get these pieces break off in asteroids, and they shoot 30,000 degrees in all directions, 30,000 miles an hour. Now, that's a supernova. That starts everything back in motion. That's actually good. That's all those materials now have been through the kiln of the asteroid wreck, the baking in the moon, what's it called, when you warm the warmer, or what's it called, slow cooker, the slow cooker of the moon, to the oven of the planet, to the inferno of these materials have been baked. Like these 125 different elements have been through the collision, the millions and billions of years this, and the billions of years this, and then the fucking billions of years this, and then boom, it shoots them back out, and it's a brand new hybrid. All the fucking, every single element that just comes out of this is, so Earth is gonna have 150 elements next time a major fucking next time, like, it's gonna keep growing and growing in new elements because every day new ones are falling from the sky. We just have to get enough of them to identify them and figure out what they are and add them. Because now, look, so let's say this is a first generation set of materials. These materials went through this process, and that's their first time because they're brand new from this supernova over here that was in the very beginning of the system, because its materials have been golf falling forever, and they just finally someone finally grabbed them and used them, and so now they've lived through this cycle, and now they've been changed, and now they're Gen 2 element. And they get shot back out into space, and they go through another system, and then that system blows up. That's a Gen 3 element. And so these our materials are going to keep advancing and keep becoming new, like titanium and like chromium. We're going to have new and new and new and newer and newer, like gold, aluminum, titanium, diamond. All this stuff is where this comes from. And however, we don't know if gold is from like a 16,000th generation hybrid, and silver is like Earth's first original. We don't even know anything yet. We'd have to go everywhere else to see, like, but we just know what we have here, and so we have no idea like the correlation between any two elements we have here. One could have came from here yesterday, and one could have came from here 10 zillion years ago, and and then another one could have been made by Earth today or this, right now, but so that's how it's feeding the rest of the system, and that's how it's making these are obviously just like cells growing, and then they grow, and then they roll over a new life form, kind of like the butterfly, the caterpillar, the butterfly. These things are growing sun to the next sun is more advanced materials and that it starts with, so more advanced that it puts out when it blows up, and they just keep feeding it back. Now, what is a black hole? This is where I am probably the best you'll ever hear about this until you hear me tell the world about this, because this is what a black hole is, because nobody knows what a black hole is, and I'm one of the few people in the world that does, and she was going to argue with me about some of this, and that's so stupid, because we just talked much in length about asteroids falling from the sky and moons getting caught in orbit and all that, and a shooting star is just you seeing an asteroid veer off of its path, and you don't see it until it hits the air. Once it hits that electromagnetosphere and it comes into the sack of air pressure, poof, it lights up and you see it, and then you see it burn out. And that's an asteroid falling in. That's Earth getting bigger. That's the growth that's Earth growing. That's like your little cells when you eat a burger, getting the nutrients to them. If you could zoom in and see the little cells of our body getting the protein and stuff out of the food, it would look much like an asteroid running into, the system is living. It's totally alive. And so now, what is a black hole? A black hole, so you've got a star. It's at its maximum size. It's nuclear fusioning. If that star runs out of fuel abruptly, it shrinks quickly and it explodes. If that star has a slow trickle of new fuel that's almost enough to keep it alive, or a sporadic run out, some cars sputter for 5 miles before they run out of gas, and some just shut off. If your car shuts off, you supernova, because you shrink and you crack and you explode. But if you're one of those cars that can hiccup down the road for 5 miles, you slowly crash land your egg. As it slowly cools down, everything has a better chance done gently, slowly, right? So if you can slowly cool down, and it's a very delicate process, but if you can get it to just slowly go down to a chill, and then it's cracking, but it's just doing it slow and gentle, and it's like dusting and filling back in as it goes. It's like crushing itself slowly. It sounds different than you're used to if you're a planet guy out there, and you see it just, and you're like, oh, don't touch it. Don't touch it. I think it did it. It did it. That's a black hole. So what a black hole is a star, aka a sun, the sun, burned out